I'm actually really happy to be giving this talk. This is about a product that we offer externally, Velocity Analytics. It's actually also a product that we're using a lot internally now, particularly in the Thomson Reuters labs. So Velocity Analytics, it's a solution for your data management and analytics. And it's all on a single platform. And the main thing we're going to talk about is it is powerful. And by powerful, I mean sort of from a raw technical power point of view, but it's also sort of powerful to transform the data and do the analytics. And I also want to say it's powerful in the sense that it enables people like myself as a quant or quant developer to actually faster develop, test, deploy the applications. That's really what we're about when we talk about this product. A little bit about myself. I'm actually part of Thomson Reuters labs. I'm actually a machine learning engineer as well. Our purpose in the labs is really to span across the different aspects of the business. Ultimately, we're trying to help the customers find the new value within their data. I work in a global team consisting of data scientists, research scientists, full stack developers, and designers. And we would say that we consider ourselves more of an innovation team, particularly when it comes to new technologies like the A8. I've given a quick slide here. You can see down the bottom, the emerging technologies really spans everything that we do. A lot of portion of my time is actually just spent working with technologies such as this, a host of other technologies as well. I wanted to give you some context in terms of what VA8 can do. Now, when I talk about a product lifestyle here, I'm really talking of this as a quant or like a machine learning engineer. We typically talk in these three realms. They're not siloed, they often overlap. We talk about the data at Thomson Reuters. We also talk in terms of the content. We talk about the model. That's really where the intelligence of the system sits. And we also talk about the design and the UX. And this is actually a hugely important aspect of everything that we do. I'd actually say in financial services, it's something that hasn't really been addressed as much as in other areas. But it's something that we find crucial, particularly in labs where we're trying to deal with customers day to day. You do all this, you build applications, that's what everybody does. And when we're talking about applications for this talk, it's everything that we're talking about in the financial services, order book reconstruction, regulatory reports, everything that you see on that screen. I do a lot of algorithmic execution, best execution, trade cost analysis, that sort of thing. I really want to emphasize that each portion that we're talking about here with the data model and design, it's hugely important in its own right, and each part is totally critical. So when we talk about data with Thomson Reuters, this is going to be ever more important in the future. I mean, people say things like data is the new oil. Companies that can produce their own data, they're going to become ever more important. And so when we talk about the access to data and the ability to have a lot of different data sets at your fingertips, it's really important, and it's only going to get more important when you start combining this with the intelligence that comes with models. Now, I spend a lot of my time modeling. I'll actually talk a little bit more about this right at the end. But basically, with a model, you just want to access as much data as possible, and I think that's pretty clear. I'd also say that what you really want to do is to slingshot yourself into the design and the UX aspects of what you do. And so that's really what we're talking about when we try to offer products like VA8. We're trying to find a way that how do we do this the best and the fastest. And so we're really talking now, when you look at all these different applications down the bottom, you can imagine in a large organization, we're talking about different business units, and these are often disparate technologies. And so that's why we have Velocity Analytics. And it's combined with Thomson Reuters Electron data as a platform. It's actually a very powerful solution. It does all your data management and analytics, single platform, and it caters for a very large range of use cases. I'll say it's completely for low frequency data or high frequency data. It does a lot. It's powered by the KX systems. That's the underlying technology, if people are aware of the KDB database, which I've used quite a lot in previous roles as well. I'm going to place a bet that a lot of people in the audience are aware of that database. So that actually powers it underneath, but I want to, and for people that aren't aware of it, it's actually just the leading time series database for financial data. It's used across the street, very popular, been popular for 20 years. So that's what powers it underneath, but I want to make it clear that Velocity Analytics is actually much more than that in terms of it being a managed service on top of KX. It starts with the data, as I said. So the different data sets that I want to show you here, it's actually worth just having a quick pause to say that this is fully integrated with all of the real-time, historical, and fundamental pricing reference data from Thomson Reuters. This is the best-in-class data that the street has. This is why we've offered it in the way that we do. And the reason that I say it's at a single unified platform is because you can actually put other data, your own proprietary data, using different things like fixed connectivity, to actually merge and have the single unified platform for this data. I think anybody that's actually done this in practice, this is a big deal. This saves you a lot of time if you just have the one spot to go to. The fact that we normalize a lot of the data also, this does save a lot of time. I'll show you a few examples of this in a tick. But the fact that it's all combined together in the real-time and historical to allow you to do the complex analytics that you need to do in the single spot, this is actually what slingshots you into this analytics as a service, analytics services, where you have all these different use cases that we can show on screen. I would say that everything that we offer, including things like the MiFID II analytics, where these are particular use cases where you have a myriad of sort of reporting and monitoring requirements that can be done in a single place. This is more what we should talk about as the developers, because this is kind of the endpoint for VA8, and this is what we access. I'll actually probably focus more on the data sandbox on the side of the screen. That's more where I sit as the quant developer, but there are other ways that you could access this, particularly with the dashboards, and that's why I mentioned MiFID II. That's actually a pretty good use case that we have where it's a specific use case. We've built a dashboard for you to actually access and do your best execution reporting for MiFID II in a single spot. And this, for people that have done this, could appreciate that this is actually a huge step forward as opposed to having to manage this sort of stuff yourself. So I think the very good question is what makes it different? So I think the current state of the industry is that you do actually have a lot of disparate technologies. And this isn't as much a problem that they're difficult to maintain. Things like service and support across different business units can be actually quite a problem. And as developers, you could probably see that this is a major value proposition. On top of that, and I'll just say here again for the performance with KX, it is actually like the leading time series database for financial data, and it's very well established. So this sort of summarizes everything I've just said, and I'll put it back now in the context of the fact that you have on the left-hand side the data, and we really want to get to the endpoints in the model on the right-hand side, and this is actually where I step in and start using VA8. So we do this in two different ways. The first one is just directly with the Q language. So the Q language is what is used in the KDB database. There are plenty of IDEs out there for you to use those. But we also use very often the machine learning algorithms and the programs that you see down the bottom. And that's actually where I spend most of my time when it comes to doing the heavy processing that I want from VA8. I've also just snuck down the bottom there things like TensorFlow and PyTorch, because we all know that this is coming. So these are the sort of technologies that are going to be enabled by having a large amount of data for ready access for developers. I'll also just jump in here very quickly and say that with the Velocity Analytics, it's a managed service. So you get things like reference guides very easily. I'll actually just show you here, if that is a bit big. So this is just like a couple of screenshots that I have of the reference guide. It's all fully managed. You get to a full understanding of exactly what's going on there in each and every function that we offer. I won't spend my time on that. I'll actually just start to use it. These are the main 5 functions that you get straight out of the box. They're sort of a self-explanatory, and a lot of the stuff in VA8 is. I've actually found it quite an intuitive thing to use. So things like get ticks, that gets you the tick data, get stats, that gets you summary data, get bars, gets you aggregated data over short time frames, summary and ref, I'm sure you can understand as well. I wanted to give you a few examples just to jump into a notebook so you can actually see how it works. So this is actually just an example query that I've taken from the reference data, and it just sort of highlights a couple of things. First of all, for those of you that have never seen Q before, at the top is actually a very simple standard Q function. It's just essentially just getting some tick data. You can see the top line of the argument names and the bottom line of the argument values. We're just returning, I think it's about a couple of days worth of data for Barclays, and we're just displaying a little bit here. But it actually brings to the forefront exactly what I was talking about with the normalization of the data, which is on the right-hand side with the condition codes. And anybody that's used tick data knows that this can really slow you down if you get it wrong, particularly if you're talking about 2 different groups. I mean, just the simplest thing that if your research group is filtering your data on a different condition code to your trading group, you know that's going to be a problem. And having the single unified system to do this helps you a lot. This is just a short video that we made of exactly how I use Q IDE called Chrome Q. You can see here I've just done a quick query here to get some get stats data. You can sort of sort through it, go to the end of the data. It's pretty straightforward. This is actually how I use it. There's no magic here. Things like you get the stats, you can start to look at the max price for particular time frames. This is another one where we focus on the cell volume only, so we just reduce the data set. And the whole point here is that you can very quickly, through a large amount of data in your back end, you can actually aggregate it down to the useful data that you want to do whatever you need to do with that. And that's exactly what I'd like to talk about next in an R notebook. So if I go here. Okay, so these are just a few examples of how we use Velocity Analytics, and this is exactly what we do with a bit of gear. So first of all, you just connect to the database in R. It's a simple one-liner, which I've hidden from you there because you'd see my password. But it really is just that. You open up a connection. For anyone that's actually used this, you know how easy it is. We can just go through and just pass the execution, so the execute statement there. And these are the select statements, so very SQL-like. You can actually just pass those directly through strings in R. You get it directly back as a variable in R. Everybody that's used R or Python is actually very similar now. The time series functions that you get in R and Python, these are fantastic. You can actually process a lot of data on that side as well. But the advantage here is that on the server side with the KDB, you can actually do a lot more processing, a lot faster to aggregate and get down to the specifics of the signals that you need to pass back into your R or Python and do your machine learning and statistics. And as I said, this is exactly how we do it. So just a few quick examples. Here I'm actually just getting the open, high, low, close for one particular RIC. I think we're getting it down onto 10 minutes here. So this variable here that you see, that one there, that's actually saying I just want it every 10 minutes, so we're aggregating it. That's what the getStats function does very well. It's very fast, so we end up with the open, high, low, close. I can throw that through into digraphs, and we get a candle chart with just a few lines of code. You can start investigating straight away. As I said, completely typical use case. Now, when it comes to building your own analytics, which is what a lot of you would like to do, again, very simple. So again, we're doing here the getTix function, so we're actually getting the raw data directly now. And what I'm doing here is I'm just calculating the simplest that I could think of, which is just the average bid-ask imbalance over, I think I've gone down to the minute here. We could go down to the second as well. But you could go down to the minute where you just take the average difference between the bid and the ask size over a short period. I also get the average midpoint price. And if I get this correctly on the screen, these two I've just connected in digraphs. So at the top one is the price, the bottom one is the bid ask, and you just start to, down the bottom is essentially a signal, and the top is the price that is responding to. Again, you can start to say, well, okay, can we start to flog it, essentially? And yes, we can. So this is looking at the order book depth data. Now, a lot of people, when they think of order book depth, for people that haven't used it, it can actually seem like a lot of data, and it is, and that's kind of the point. But there is actually a lot of information in that data too when it comes to the price discovery on the microstructure scale. So what I'm doing here is actually very similar again. It's a very similar getTix query, but this time we can add in variables to say, get me 10 levels of depth on either side. In this particular example, I actually take everything there, so you can see in the R notebook, we can just start investigating it as we need to do. In this example here, what I do, is that too small? I might have made that too small just in the last screen. What we can do here is actually look at the bid volume and the ask volume in aggregate on either side of the order book. We can sum them up, we can normalize them, so you end up a signal that goes between -1 and 1. And again, you're essentially looking at, are there essentially over the 10 levels a bid-ask imbalance? And so I do very similar to what I did above, and I'll just reduce the screens there. So you end up with a plot like this. This is for a whole day's worth of data. I mean, it's very quick to get all this data back. And again, you can start to investigate your price series movement over the whole day with the and this is at second resolution. It's actually more of an issue on the R side than on the KDB side when it comes to processing this. But this is quite simple. This has no problems doing this. But you can see at the beginning of the day, over the first few minutes, we're talking again the first 10 or so minutes of the day, there is a significant bid-ask imbalance over the first 10 levels there. You can see that as the signal, and you can see the price reacts to that. Now, I'm not going to say that's price prediction, but that's exactly what people look at when they talk about these sort of price prediction models. And that's how you can sort of harness the processing power of KDB on the server side to then do what you need to do on the front end. Now I'm going to finish with something that's different to what I've just talked about, because this is exactly where we're at as an industry. So this time I actually just take similar to what I took before, open, high, low, close with a VWAP included as well. And I actually just do a very, very quick one-liner, and I'm going to call out Tim Nugent, who'll be speaking after me. This is how easy it is to do sort of statistical analysis and forecasting now in things like R and Python. It's a very simple, it's called the exponential smoothing state space model. A lot of it is done under the hood automatically to choose the right model and parameters. I'll actually just jump back into the PowerPoint here to explain this. So the ETS is actually a model. There was a recent paper that came out. This is a very high-level summary. It actually had the best error rate compared to a lot of different machine learning algorithms out there as well. It's a very recent paper. We're discussing it a lot. But this is where we are in an industry that I just showed you. You can do that in one line of code. So if you're a developer and you get access to the data, you can definitely do this yourself. Yeah, it is literally one line of code. So when we talked at the beginning about data model and design, really what we're seeing as an industry is that model is being condensed from a developer point of view into a very small subset of the overall. Now, I don't want to say that the model is not completely critical. It's as critical as it was before, but I'm saying that through things like velocity analytics, you're now able to maximize your time understanding the data and spending more time in your application and your customer and your design than in the model that you did before. I'll finish there. I'll just say thanks to all my colleagues in Thomson Reuters, very much surrounded by some very good people, in particular Gamley, who helped me very much with this talk, and Tim Nugent, who'll actually be speaking next. I'll do some very quick Q&A, but I know that we're probably close to time. If anybody has any questions. Nope. Yep.
Can you expand a bit what applications platform can have in the sphere of post-trade analytics?
In post-trade analytics, do you mean specifically for post-trade analytics? Because that might be something that might be easy to talk about later because we actually have quite a lot. It's sort of one of these things that you could sort of build yourself if you wanted to start there, like kind of like what I was doing. But it might be one that we could actually talk about. There's actually like quite a few nuances there that we could go through, if that's okay. Yep. Okay, thank you very much.